Okay, close.
Jeff?
Yeah.
Will be at 12 a.m.?
I don't understand what the Q,
Okay, it will be 12 p.m., right?
T line about
It's a vision exam.
I do my homework. And I don't,
Yes.
I've never seen that.
From my memory, I thought it was supposed to start around midnight, but I could be wrong. I've been known to be wrong. All right, so first let me show you.
What is tab hop? You have a military discount?
Something kind of cool. First of all, I don't know if you guys know this book, so I read it.
Yes. It's a bunch of interesting stuff.
So here's something kind of nifty. Now watch. This is back in 2002, I think it is. It's a comet that almost hit Earth. You're all sitting there saying, great, my math teacher's talking all kinds of weird shit. But do you see how, I want you to really notice, this is a comet. Here's Earth and the Moon. Back in 2002, this is what that comet actually did. And the most important part for us,
It's going to come back though because it's in orbit.
this guy, I don't think it's going to come back. It's an asteroid. My bad. I'm calling it a comet, but I got comet on my brain. So this guy is not going to come back. It just got captured by the Earth's gravity, came in. Now look at this nifty. Anybody ever play the game Spirograph where you get the gears that fit into each other? So it sort of looks like one of those things, right? Now we're not going to get into the physics of it or anything. All I want to do is, we see visualizations like this all the time. And without these visualizations, if you just give me numbers, it doesn't mean a damn thing to me. I want to see it. As a human being, I want to actually see how close it gets to us. We're zooming in, and then the asteroid comes in, and it comes over towards us, of course, because we're pulling it in, the gravity. And the moon and all that kind of stuff is kind of pulling it over too. So that's what makes this weird thing. But what this is notice, there's something here, there's something here, and what I'm doing is I'm plotting points. So at this time, and see how the time is running along, September 21st, just past my birthday. At this time, the comet, the asteroid was here, and then it kind of moved down a little bit further along, and we plot also where the Earth is. So this is what I was talking about, the equations of motion, and we can see how they're going to pass each other. And thank God, nobody's equation of motion actually crossed at the same time. You with me? If it would have ran into the moon, that would have sucked. You're all looking at the moon and it just blows up. We're like, oh, okay, that's it for that. All the tides are then gone. Right? That's what causes the tides. You just have a boring ocean just sitting there.
You gotta do like that movie Armageddon.
Armageddon, exactly. Yeah. Anyway, so that's one thing I want to show you. And I know this doesn't have an immediate, seem to have an immediate tie-in to what we're going to be doing. But we are going to be graphing equations. And it's going to seem, first off, a lot of people don't like graphics. Normally right up near word problems with what's difficult for them. So I don't know if you've done a lot of graphing at all and how you feel about it. Anybody feel almost as bad about graphing as they do about word problems? A few people, okay. But I always want you to keep in mind that whatever the equation is that you're graphing, it could actually represent some kind of motion of something. So if I graph two lines at once, I can see if they're going to hit each other. Right? Train A and train B, and that's not good. Yes, sir? That's what we're going to talk about today. Graphing is... Watch. So watch this time here. See April 1st? On April 1st, so this represents April 1st. On April 1st, it was right there. So I plot a point right there. Graphing is just putting a point, for example, in this case, where something was at what time. So all graphing is taking points and plotting them. And we've graphed already. You guys remind me, I'm going to let that keep rolling because it's kind of neat. You guys remind me, how do I graph x equals to 2? How do I plot that? This is the most basic graph, and we've done this already. How do I plot that?
Wait, quorum on 2.
Put a dot on 2.
Put a dot on 2. All right, so that's almost too easy to see why the hell we do that. Right? It's not very useful by itself. But, for example, let me give you this example. Let me turn my camera on. So I looked this up earlier, and let me show you something kind of neat. So this is the normal, it's like the average growth of women as they grow up. So at 2 years old, they're 34 inches tall. You guys see how that works? These two numbers go together. I wouldn't want to tear them apart because 2 years old goes with 34 inches. You guys got it with me? So a little 2-year-old girl, on average, they would be 34 inches. Anybody have kids? Have you guys seen those charts that kind of go like that? And it tells you the range in which your kid should be. So the tallest your kid should be and the shortest your kid should be. So if your kid's there, you're like, uh-oh, I should probably be feeding them more. Or if your kid's there, you're like, oh man, well, good scholarship for basketball, man. You with me? Alright, so even if you don't have kids, those exist. And they're plotted the same way we're going to plot things today. They go along this much, and then they find where it is on this one. So we're not quite there yet. I'm getting a little ahead of myself. But just without even thinking mathematically, this by itself makes sense. At 2 years old, average of 34 inches tall. At 5 years old, average of 42 inches tall. At 8, 50 inches tall. At 11, 58 inches tall. You guys kind of with me?
Yeah.
Some are shorter, some are taller, but this is just an average. Do you guys see a pattern? And I should have brought it with me, but you gotta trust me. I took this data directly from the Center for Health and blah, blah, blah. So it's where they produce these graphs from. I took this data directly from there. I didn't make this up. But does anybody see any patterns? Beyond just, as they get older, they of course get taller. I like it longer. Lay down, kid. No.
It's going to start
Three-year patterns.
It's going to start arcing.
Yeah, eventually it should. I like it. For quite a period of time, it is straight. But I know that this pattern, here's the pattern I'm talking about. In 3 years, how much do they grow? 8. And then another 3 years. Another 8. And then another 3.
8.
Now, can that pattern go forever? No, because when you get 62, you got a 50-foot tall woman. Right? That's not good. You guys kind of with me? So obviously, I agree with you. It looks straight for a while, and then somewhere it's got to curve off. Thank God, so we don't have these, beyond Amazon women running around terrorizing everybody. You guys kind of with me? So this idea by itself exists. This idea of a table like this. And this, I really am trying to show you real world things that you see. You see images, you see these tables, and relate them to what you're going to be doing mathematically. All right? So this right here is what we call an ordered pair. Because if I write it like this, what am I saying comes first? The age. And what comes second? The height. You got it backwards, Carl. We'll get to it. Yeah, alphabetical order. So at 5, it's 42, so forth. So I call these ordered pairs. They're pairs because they go together. I can't put 8 with 34. That'd be really short kids. Like, kid, come on. What's wrong with you? Get up there. You guys kind of with me? Yeah. So they're pairs because they have to go together. They have to stay together. And they're ordered because the first one means something and the second one means something else, right? You've shown, I've already set it up to be years, comma, height. So if I put this, that's kind of freaking me out. Well, it makes sense here. That would mean at 40 years old, they're 4 inches tall. No, the order was wrong. Are you with me? So that's why it's called ordered pairs. All right, that's exciting. All right. Now, the next step to this, really, is how to make this into a visual. How to take this data and make it into a visual. So I know how to plot single pieces of data, not pairs of data. I know what to do if I have one number. I just put it as a 2. You with me? And if I have x equals 0, okay, I plot 0. Right? But I want to show at 2 years, this person is this tall. I want to show that all at the same time visually. So the way we accomplish this is by not just using an x-axis, right? This is called the x-axis. We also throw on top of it, yes, a y-axis. So that I'm able to move in 2 different directions. So based on my data here, my real life data, what does this here axis represent? So that would be
2
years. And this would represent height. Alright, so I really want you guys with me. So I have 2 separate pieces of data, but I can put them both on the same image at the same time, because this direction is age. So if I go this way, the girl is getting older. You guys with me? And this direction deals with height. So if I go this way, the girl is getting taller. So I expect, if I graph this, I expect to see something like that, right? As they get older, they should be at the same time getting taller. If I graph my kid's height and it goes like this, something is very wrong. Right? I probably shouldn't put stuff on the head. Oops. I should not be a parent. Thankfully I'm not. Alright, so, you guys, I really want you with me. We should totally understand. I want this here all the time when I'm doing this. We should totally understand how to graph x equals 5. So that means I just go 1, 2, 3, 4, 5. So x equals 5 means go left or right. I know I've got to go right because it's positive 5. Go right 5. So when I want to add in another variable, now here's what's kind of cool. You actually are adding in another dimension. With just this, you're only able to move left and right. That's a single dimension. If you can only move left and right your whole life, you're screwed, unless where you want to go is on that line somewhere. You with me? So I want to be able to move up and down. And that direction is controlled by another variable. Yes, sir?
So basically you're just dealing with integers, huh? And integers kind of...
Integers makes it easy to graph, but I definitely want to know how tall somebody could be if they were 2.1 years old. So what we normally do is we graph the easy points and then we fill in the line, and it captures all the middle points, like the 2.3s and the 2.796. I don't want to graph all of those necessarily. Yes, sir?
I don't get it.
You're not alone, brother.
Give me some time. Now let me know.
Is there a name for the left-right line versus the...
This is very often, this is just called a real number line. So now we know it's called the x-axis. Right? Not like the axis of evil. Or is that too old of a reference? Sorry, some of you guys got it. It's called the x-axis because what variable do I normally put on there? X. Cool. So then I can introduce a whole other axis. Because what do I have here? How many things do I have going on here? How many ideas? 2. I have how old the person is and how tall they are. So I can't just represent that on a single axis. It doesn't make any sense. I need to have another direction to show this. And it's actually going to make physical sense, because the more older I get, the taller this thing should be. That makes physical sense. It's the taller my kid is. Right? So how would this look? Let me plop this back up here. Sorry, asteroid. Alright, so there she is. There's my, what's this? X-axis, I love it. This is my x-axis. And this is my y-axis. So for example, to plot the point, let me collect these over here. So if I write these like this,
So is X always the horizontal and the Y?
I love it. X is always the horizontal.
Y is
Y is the vertical.
And X is always the first number.
Good. And then it's in alphabetical order. You gotta love it. X first, Y second. So, for example, how would you describe to somebody to get to your house? You know, if you're here and you live there, and these are blocks. So how many? You got to go 3 blocks up. 1, 2, 3,
And 1, 2.
and then 1 block over, right? So the over is the X. So if I want to describe how do I get from here to there, I got to go 3 up and 1 over. So the 1 over would be, actually let me do this a little better. Let me use this graph I actually have. So let's say I live here. I live right in the center of this thing. So my world is centered on me, right? Just so you know. And this point we call the origin. And it's got an ordered pair. It's got this ordered pair idea.
Thank you.
Ordered pair, very often we also call that, I should have heard this word in some movies at least, coordinates. Right? What's the coordinates of the alien plane? There's over there. Right? Or whatever movie you haven't even watched. So if I'm at the origin, if I'm at the center, I haven't moved left and right at all, I haven't gone up or down yet. So it kind of makes sense that this is going to be the point 0, 0. This is the origin. This is where everything starts. This is the point 0, 0. So if I want to go to the store that's right there, how far over do I have to go? 2. I got to go over 2. And that's, of course, which axis is that? Which direction this is?
Positive.
The x-axis, good. In the positive direction. So I've got to go over 2 and
Up 3.
up 3. So this ordered pair, these coordinates are instructions on how to move around on this grid. Yes, sir.
That's 5.
Say again?
That's 5.
We're not adding them.
Adding.
We're not adding them. So to get somewhere, I've got to give somebody 2 pieces of information. How many streets over do I go?
2.
And how many streets up do I go?
3.
So putting them together wouldn't make any sense because then I don't have enough information. I need 2 separate pieces of information. How far over I go, how far up I go. So that's why these can't go together. They just are listed together. I've got to go over 2, up 3. How would this for? Yes.
Is this the same kind of principle, you know, for like nautical maneuvering with the charts? With
Latitude, longitude.
Longitude and latitude? This is kind of the same principle?
Yes. Latitude, longitude is your classic example of what this is.
What does longitude and latitude mean?
On the globe, when you see the lines, and you want to find where you are, let me show you.
Oh, you're lost, of course.
Yeah. Let me find it real quick. Is there a sign?
Does it say you call that a grid? What kind of graph are you using?
It's really tiny. What's that?
Is that grid? What kind of graph are you using?
Yeah. Hey guys. Hey. Alright. It will help your understanding. So pay attention. Let me find a decent picture here. Alright. So the globe, of course, is not flat, but when you make a map, you actually kind of flatten it out. Right? So you can have this map opened up, but on a globe, these, of course, are the latitude lines. You always remember that because they make the rungs of the ladder. And these are the longitude because they're long. Right? I don't know if you guys have done much map use besides Google Maps and just tell me how to get there. Right? Apple Maps, hopefully not, or else you never get anywhere. So we're roughly at the 38 degrees latitude, and roughly right here at about 120 degrees longitude. You guys kind of with me? Okay. So, sorry, what's up? Have you ever seen latitude, longitude before? Have you ever noticed that on a map? These lines. So if you're in a boat, one way to kind of keep track of where you are is latitude, longitude. You can report to somebody your latitude, longitude. If you ever saw that pathetic attempt at a Superman reboot with a while back, and Lois Lane faxes him the latitude, longitude of where the ship is. Right? They put the numbers down so they can go over and down or up and say, oh, they're there. If you show me how much do I go over and up, I can go to where you are. So where's 0, 0? Here's 0, 0. There's the 0, 0 mark. So if I had a boat right there, I would tell somebody I'm at 0 latitude, 0 longitude. That's where my boat is.
Almost Africa.
Exactly. Almost. Thankfully, we're not in Africa. Or my boat is probably not doing so hot. Right? So if I am up here now, then I would be 20 up and 0 left and right. If I don't move left and right at all,
0.
what's my X piece?
0.
And then I go up 20. So this point right there would be the point 0, 20. So if I want to go to this point right there, let's say here. How much do I go over? What's this line? Follow it back up. 60. See how it curves. Now why does it curve? Because the earth is curved. It's crazy. So I want to go over 60 and down 20. So that would be, if I wanted to make this more like what we're doing, it'd be positive 60,
Negative 20.
negative 20. Do you guys see that?
Yeah.
I have to tell somebody negative 20 or else they're going to go there. Right? You're not going to find my plane. Like CNN is the only thing that can report it. You guys kind of with me? Do you guys watch news at all? Malaysians?
Still looking for it.
I know. That's what I'm talking about.
That's crazy.
This is basically Thomas Guide.
Yeah. So again,
Same thing as Thomas Guide, like, the real map to actually find.
this is a real map, but you're talking about one that's a little more localized.
Right.
And then you have much more defined.
But
Oh, charts.
Same exact thing.
E tribe.
Yes. You see the N, whatever, E, and the W. Yeah. Yes.
Is that adding? Are we adding?
No.
We're locating this.
This kind of math, exactly.
Representing.
This kind of math is all about locating positions. So if I wanted to find a place, so for example, let me see. You, what's your name again? Yes, don't worry. Regal, don't worry. You're not in trouble. You are my 0, 0. All right, that sounds very strange. You're like, what does that mean to you, Jeff? You gonna give me a card? You are my 0, 0? No. You're my 0, 0. You guys kind of with me?
Yeah.
He is basically the center of the room. Right? So let me look this one. Let me come over here with you. There you go. Alright, you're 0, 0. So if I go that way, that's positive. I just wish these rows were a little bit better aligned. So if I wanted to find Josie, I've got to go 1 back. So what's my X part?
Negative 1.
I've got to go negative 1. See, I'm telling somebody. This is all about finding something or someone. I'm telling somebody, how do I get to Josie? I go 1 back, and then 2 up. So that point would be negative 1. I'm not adding them. So if I want to tell somebody how to get somewhere, I've got to tell them how much left and right to go, and how much up and down to go. Or if you like it, how much west and east to go, and how much north and south to go. I can't add those together because then there's not enough information. So I got to go 1 back, and then 2 up. No, I'm not adding them. They have to stay separate. I need 2 pieces of information. No, well, I got to go 1 back, and then 1, 2. How many steps do I have to take? Randy, how many steps do I have to take? 1 to get here, and then how many to her? 1, 2. If you take 3 steps, you're up at my camera. With me? So 1 back, and then 1, 2 steps up to Joseph.
2.
2. Exactly. How many steps? If I take 3 steps from him, where am I going to be? 1, 2, 3. I'm going to be there. And she's still there in the water saying, help. Right? Okay. It's all about steps. How many steps do I have to take? I only have to take 2 steps to get to Josie. She's only 2 people away. So, alright. This is your classic example of what a coordinate system is all about, these ordered pairs, right? So it's really just, and obviously, this is useful, right? There's no question that this is useful. Latitude, longitude, stupid useful. You're out in the ocean, you want to tell somebody where the hell you are, you can't say I'm right next to the Starbucks. They have not done that yet. They don't have the floating Starbucks. What would you like today? I'd like to get home, right?
That's why they navigate by the stars.
Yeah, so they have a
Celestial
Starbucks.
navigation.
They have them on carriers?
It's all computerized.
I wouldn't put it past them, so I didn't know if you were telling the truth.
I mean, celestial navigation is they do it by the stars.
Exactly.
When they-
Right ascension and declination, same thing, just up on the sky.
You know, one thing with, in Australia, when I tell people, what's it's like, on the east coast of Australia, they're almost on the same longitude, latitude as San Diego, or Southern California, so we kind of have the same air dry climate. And if you look, you can see it on the longitude, latitudes. On the east coast of Australia, Brisbane, Sydney, Cairns. No, I've been there many times.
You know, that's 160 there, and 160 here. Nah.
Close to, similar, almost the same
Okay.
longitude, latitude.
Alright, so let's take a step back into math. Let me really show you how this works, because some of you guys might just not like maps. So let's kind of get away from maps for a second.
Oh, the chart. I did a very good job about that.
Yep.
It's not a map, it's a chart.
Alright. Thankfully, this is not a cold class. So I'm going to call it.
Navigation.
Yes, sir.
So why are we not adding?
Because that's not the purpose. It's not the purpose. Oh, let me turn this back.
So no adding?
No adding. The purpose of this is to locate something. Guys, the purpose of this is to locate a position. Right? I turned him off and now he doesn't want to come back on. Come on. Alright, stay on.
I like to take my boat somewhere where the GPS coordinates range 0. That'd be kind of cool.
Alright, make my
Instead
little
of
graph.
249 or something.
Alright, now, go with me. Who gets the basic idea here? A few of you guys. So, you guys who get it, be quiet.
Okay.
So this point there. Alright guys, so,
Camera's not facing.
oh thank you. I need a cameraman. This point right here. Guys, this point right there, how would you describe where it is to somebody? Because that's what this is really all about.
Are you asking us? 2-1.
Yes, good. Why would you say 2-1? Why you say
2 to the right,
Because X is first, X is 2.
Good.
So you gotta do that first before you go up.
okay? All right, Carl. The x-axis is all about moving left and right. The x-axis is all about moving left and right. So the amount that you have to go left and right from the center, from the origin. The reason it's called the origin is that's where you always start. So to locate that point, if you start there, you got to go 2 over, and that's the x-axis. So that goes first. And I want you to really realize this is not actually even math we're doing right now. We're just saying, how do you find somebody? So if I wanted to tell somebody where they were in 2 dimensions, I have to give them 2 pieces of information. Because how many ways can I move? Left and right, up and down. So I need 2 separate pieces of information. Yes, sir?
Why we can't go like up and go
Sure you can. Hell yeah. How much do I have to go up?
1?
But be careful. Which letter is that?
Why?
That's the y-axis because that's up and down. So if you go that first, you just got to remember to put that last in your pair.
I know, like, yeah, but we can't say 1, 2. It's wrong.
You can't say that, no. Because it's accepted to be x, comma, y. Yes,
So
sir.
that's 2 spots on 2.
2 spots over and
do 1.
1 spot
One
up.
spot up.
So that point is the point 2, 1. How are we doing there? That by itself, how is that? Is that all right? So what about this point right there?
2. 2.
Negative 2.
Negative 2, 2.
Good, because again, starting here, how far do you have to go left or right? You got to go back 2. So that would be negative 2. And then how far do you have to go up?
2.
2. So again, it's not even mathematical yet. It's just how do I get from here to there? How many blocks over, how many blocks up? That's really all it is. Because a lot of our cities are based on a grid. So it actually works beautifully for that. Yes, sir?
So whenever you go positive, you always got to annotate it by 2.1. And if you go to 3, it would be 3.1.
No points. Be careful how you say
Or
it.
3.1.
Yeah.
4.1.
Yeah.
5.1.
Yes.
Okay, 5.1. 6.
So this,
Okay.
yes. And then 7. So if I have, let's say this point right there. What point is that point there?
0 and 1. 4.
So guys, so to get to that point there, I've got to go how far over?
4.
I got to go 4 up. So which part of this would that be?
What is that?
The second one. That's up or down the second. Right? But how much over do I have to go then? 1. So that would be the 0.14.
When you
Yes.
say 0.14 though, you're meaning the point you're finding. That's
I
where
understand.
people are like, what?
I understand. This is called a point. So it's also known as an ordered pair. Or it could be called the coordinates of something. Where somebody is, it's called the coordinates. Its official name is an ordered pair. But the shortcut slang name for it is just a point. And why do we call it a point? Because it's a freaking point. That's really all it is. That is a point on the board, right? That's definitely a point that I just drew on the board. That's why I call it a point. You with me? It's just a point that I can find in 2 dimensions. Not just one that's on an axis. Not just one that's on the x-axis. Yes, sir?
Is that a time?
Could be. Could be. It could mean like 2 seconds later I'm up 1. You guys with me? A little bit. So I really want this understood. This axis here could represent time. It could represent money. It could represent age. It could represent anything. Number of dogs you own versus the grade you make, if that has any effect. You guys, yes, ma'am.
When we use the downside.
Oh, whenever I put a point down there, just haven't gone there yet. I didn't want to bring negatives all the way in too early. I just want to get the idea down. So if I had a point here, what point is that?
But how do you get the negative thing?
How do you mean?
The
If
negative.
this is 0, if this is the point 0, 0. And in fact, we already know this. Randy, help me out.
It's 2 number lines.
Help me out, Randy. Help me out. What would I put there?
1,
And what would I put here?
negative 1.
You just answered your own question, right? So if that's 0, that's 1, 2, 3. And on the other side, it's -1, -2, -3. And the y-axis, I really want this under. The y-axis is just, I've already got one going left and right. So if I want another variable, if I want another letter, guys, hey, you two, put those away. Take it outside or put them away and stay. So if I want another axis, this y-axis, I can put it up and down. And then it's still going to be positive 1, 2, 3, but the other way is going to be -1,
You
-2.
got going this
So when
way.
you go down, it goes negative on the
Exactly.
vertical? Okay.
And in fact, when you get further along in math, almost independent of what the graph is, we sometimes call this the ground, so this is like under the ground. That's why it's negative. Right? You're like 6 feet under down there. Right? Anyway, that comes into play. So this point, help me out again. Good. So you have to tell somebody how to get from here. So you go back 3, is why it's negative. And then down 2, that's why that's also negative. I like it. Cool. Okay, how we doing? All right. Yes. Oh, you're good. Okay. So here, you guys figure out where this would be. Don't say anything out loud. Don't say anything. Just try to visualize where that would be, and we'll see if you're right.
It's about, it's about like length and wide too. Can it be like length is fine.
Yeah, sure, it could be. If I laid a board down, I could say it's 2 by 4, right, or something. Yeah, it could be. So this could be used in a lot of different ways. Good. As long as you got a direction, this direction and this direction. So length and width, I can think about it the same way. So if I had the origin right here, I know you guys can't see this, but I have the origin right on the corner of this table. I could say, where's that point there? It's this far over, maybe like 4 feet over, 3 feet up. You guys kind of with me?
Yeah. 3 and 4.
So it'd be 4, comma 3 to get to over there. Okay. So where is 2, negative 3?
To the right.
Three is where you go.
Yeah, so I gotta first go
Right.
Yeah.
And go down.
No, not go.
I like it. Notice how I did not put a point there. I just put it at the end. I have to do all my directions before I can put the point. Right? I don't put a point in the middle. I don't say, okay, 2 and put, no, that's not where the point is. The point is at 2, negative 3. I like it. Okay, how we doing? Okay, good. So that's the first skill that we have to have, is just being able to locate points on the grid. And we call this, there are several different things. We call this rectangular coordinate system. Why do you think we call it a rectangular coordinate system? Because if I move around, I can make little rectangles, right? Because I want to move straight over and straight down and straight over and straight. I can make little rectangles. That's one reason why we call it rectangular. So that means in the future, you might learn some kind of circular coordinate system, right? Or you might learn something else. So, let me come back to this dude here eventually. Let me see if he'll turn back on so I can get a better graph up here. All right. Okay. So anywhere I can get ordered pairs like this. So it could be something like the age and how tall somebody is. It could be the number of hours you work and how much money you make. Right? Anything that is connected like that, I could actually make a picture out of it. Okay. Just like we just did. So, here. I want to try to do that one we just did, and I want to show you that your scale doesn't always have to be by 1, thank God. Notice there's only, if I call this 1, 2, 3, 4, 5, could I ever graph this point?
No.
I'd have to extend it, right? Well, let's just say I don't want to, I'm lazy. Or that's the edge of my paper. And it really is, actually. You guys kind of with me? So I don't have, they got it. And we already know we don't. Haven't we already seen stuff like 2000, 2005, 2010? When you've seen graphs like this, the number of people on the internet per year, right? You've seen little graphs like that. I know you have somewhere. I know nobody reads the newspaper anymore, but you gotta see it somewhere.
Stock market.
Stock market. True. So now watch. If I want to get up to 11, as long as every step I take is the same amount. If I go 1, 2, that's fine because it's by 1 by 1. So something a little bit better would be 2, 4, 6, 8, 10. It's almost good.
3, 6, 9.
Ah! So maybe we do 3, 6, 9, 12, 15. You guys kind of with me? Yes, sir.
So you're adding 3.
I know.
Just an example.
Exactly. So it's sort of related
Just
to,
showing you an example.
guys, so it's sort of like on Google Maps when you zoom in, zoom out. Your scale can change. It's got to be consistent. You can't go 3, 6, 7, 8, 20. That wouldn't make any damn sense. It's got to be consistent. So if it can go 1, 2, 3, you can certainly as all hell go 3, 6, 9. And that's fine. And you guys see why I'm doing this weird shit? Because I want to get all the way up to 11. And the edge of my paper comes too soon. And what about this way? I want to be able to get all the way up to almost 60.
10,
No. 20.
20, 60.
20, 40, 60.
Yeah, 20, well, if we try 20, 40, 60, then I'm not really
You go
using a lot.
15?
We could try, yeah, 15 would be a little bit better. So 15, 30, 45, 60, that's a little bit better. So let's try to plot these points, and let's see if this makes sense. These are points that, again, I got these from the actual data, the true data that they have for average heights of girls. So at 2 years old, they're about 34 inches tall. So 2 is roughly where? Would it be right in the middle?
No. Next to
What's right in the middle?
If you 3/4 of the way over.
It'll be 1.5.
Yeah, that would be 1.5. Are you guys with me? Because what's halfway between 0 and 3? 1.5. So it would be a little bit closer to 3.
2/3.
So the point 234 would be 2.
Up. Next.
34, this is 45, so it'll be a little bit closer to 30, so it'll be right there roughly. So that's the point 234. Let me call this A, B, C, D. This is A. What about 542?
Let's go 5 to the right.
So 5, again, it's roughly the same place.
26.
5,
And 40 up.
42, so it's almost here at 45, so it'll be right there roughly. There's B. 850.
We go 8 to the
So over 8,
right. 50 up.
and then 50. So 45, 50 will be a little bit closer. That'll be right there. So that's C. And then 11, 58. So 11,
Next to the 10.
58 is almost to 60, right? So there's D. And look what they do here. They line up pretty well. Especially if you guys draw a straight line, it'd be great.
What's that line called again?
A line.
Just line?
Yeah.
In homework, they called it something. They called it something in homework. Would it be an arc?
No. Arc normally has some kind of curve to it, right? The arc of a ball you throw, the arc it takes, because it goes on a parabolic arc. Either way, so you can call the arc of a circle. Right? How wide is an arc?
Arc of a bullet.
So you got a bullet. Wants and wanted. You make that thing curve around somebody, like wanted. Exactly. So guys, we've taken a huge step forward. You see how these line? Why would it make sense that these line up? Based on what we noticed about this data a while back. Every 3 up, these go how much?
A little bit.
Be more specific. 8. So every 3, these go 8. Every 3, these go 8. So they're lockstep with each other. Every 3 over, I go 8 up. Every 3 over, I go 8 up. That's why it becomes a perfectly straight line. Are you guys with me? If somewhere I went 3 up and I went 2 over, then that would be curved. How we doing? Wait. So things that follow a straight line, they will always have the same pattern between the points. If I go up 3, and this goes up 8, I know it's going to be a straight line. What does it work? So even if you don't get what I just said, we're marrying 2 ideas here. We're able to graph all of these, and then we can connect them with a line. So if I wanted to know, well, I've got a 10-year-old, and that's not in my data, is it? I can just kind of go up here and say, oh, it should be that tall. So that's how I can capture, I think, Randy, you were asking about this earlier. That's how I can capture all the decimal stuff. I can just go, whatever I don't have, the line will capture it. If I just connect my dots with the line. So if I had somebody who was 6.5, I can just go to where 6.5 is and just go up and say, oh, they're supposed to be that tall. I don't have to graph 6.5. If I graph some main points and then fill it in, I can then kind of figure out, infer between them. Just by where the line goes. It's kind of neat. Alright, maybe. So, all we did, I think most of us now get the idea of just how to plot these points. And then the next step after that would be connect the points with a line. Yeah. Okay, good. So, one place I can get sets of data like this is from the real world, just like I did. I looked it up and I saw how old and how tall they should be. Another place we can get points like this, believe it or not, is from pure math. I can get it from something like this, some kind of an equation. Now this equation, I really want you guys to notice what this does. This sets up a relationship between y and x. So what could x be? What does x represent?
Number.
Two.
Number.
A number. And which number?
2.
Any damn number we want. It doesn't just have to be 2. It could be 2. So whatever x is, y is 1 more than twice that. You guys see that? That sounds like what we did when we were doing word problems a while back. So I can make a little table a lot like this, but I'm not measuring how tall people are. So I'm just call them x and y. So if I let x be 2, what's y going to be?
5.
4. 1.
5.
Wow, okay. So if x is 2,
2 by
what's
4.
twice 2 plus 1? You see, I'm just going to plug that in. You guys with me? So we've done problems like this before, where I gave you like a squared plus b, and I told you a is 3 and b is 5. You just got to plug it in to figure out what it is. So if you let x be 2, you can plug that in. Twice 2 plus 1, 5. I like it. So what if x were 0?
1.
0.
Y will be 1.
Yeah, it'd be twice 0 plus 1. See, I'm just plugging it in.
1.
That would be 1. Yes, sir.
I don't understand.
So, let me go back in time. Recall. We've had problems exactly like this, where I said evaluate if x is 2, y is 3, and z is 4. Right? Do you remember those days? And those days, looking back, those are nice days, right? Before we got all freaky. So how do you solve this? How do you figure this out? How do you evaluate that? Plug it in. Because I know the expression I'm working with is x squared plus y plus z, and if somebody would just tell me what the hell x, y, and z are, I can figure out what this represents. And they just did. So what do I put here? 2 squared plus 3 minus 4. And then I can figure it out. Yes, sir?
That'd be 1.
Yeah, you get 4 plus 3 is 7. Minus 4 is 3. So it should be 3. So that's what we've done in the past. Now we have expressions like this, these equations, that say y is related to x amount. Yes, sir?
I have a question on one of these, on page 551, where one of them, it goes 0, comma, negative 1.
Okay.
You're going to go. Okay, okay.
We'll get there. Let me finish this one up. So, somebody else give me an idea. Now where did I get 2 and 0 from? Where did they come from?
Just numbers.
There's anything. Because what could x be?
Anything.
Anything. But the minute I say x is something, y is twice that plus 1. Do you understand? So x could be any damn thing I want it to be, but then y is set. That's the idea of the ordered pair. 2 goes with 5. Because 2 makes 5 come out of here. You can't rearrange those. 0 goes with 1. Yes, sir?
How x be everything if it's x?
But what does x represent?
X.
No. X represents, what's the name of it? What do we call those kind of things?
Time.
Variables. We call them variables.
It's available.
It's something that varies. There could be any number that I need or want.
You did it.
So now watch. So here's the difference between what we're doing now and what we were doing before. If I gave you this, what could you do?
Index.
Kill the X.
You could figure out exactly what x was, right? You with me? So how would you figure out exactly what x is?
Not, you get -1. -1. 2x equal 5. And x equal 5 over 2.
2.
Beautiful. X equals 5 over 2. Because if that's a specific number, I can solve for the element. I can solve for x. So x, if x is 5 halves, then this equals 6. Right? So what if 2x plus 1 equals 5? How do you solve that?
What, if you like x 2 over 5, or what do you mean?
How do you solve this?
Minus
Oh, 2x.
Minus 1?
2x minus
4.
no, 4.
X equal 2.
So 1, 2, 2.
So to make 2x plus 1 become 5, what must x be?
2.
2. What did we get when we let x be 2?
Okay, what?
We got 5, didn't we? So what this says is 2x plus 1, that value, that 2x plus 1 will equal my y piece. That's what that says. Well, what the hell is 2x plus 1? Whatever the hell I want it to be, because it doesn't have to equal a specific value, does it? Does 2x plus 1 have to equal 6? No, this says 2x plus 1 equals something else, some y. I can let it be whatever the hell I want it to be. But the minute I let x be something, if I let x be 1, y is a very specific number. It can't be anything it wants to be. If x is 1, what is y going to be?
3.
Twice 1 plus 1, it's going to be 3. So all I am doing is one level up from what we did before. You don't have to wait for me to tell you what one of these things is. You plug in whatever the hell you want to. And what you're doing is, you're making a list of points. So where did I get these points from? I got them from the internet. Right? They were actual physical data. They measured people and they averaged them out, and this is where they got those numbers. Where did I get this list of numbers from? That equation. So what we're about to do is, we've seen stuff like this before. We're about to see what that looks like visually. We're going to look at what does this thing look like. Y equals 2x plus 1. What does it look like visually? Yes, sir?
So you say you're not adding.
This equation has a plus in it. So I will definitely add when I'm trying to figure out what that value is.
But you said we're not adding. So you the graph.
True. So what points do I go through? What's this first point? What point is this?
2.
Yeah, x is 2. Y is
5.
5. So that's the point 2, 5. What point is this one?
0, 1.
0, 1. When x is 0. So when x is 0, that's the first piece. Y is 1. I like it. And then what's the...
1.
There you go. Everybody can look together. And then this guy is going to be
1, 3.
1, 3. When x is 1, y is 3. When x is 0, y is 1. When x is 2, y is 5. How long would this list be? The total list.
Long. So long.
Beautiful. That's the exact right answer. Long, freaking long. Right? Because how many numbers could I put in for x?
Whatever.
Yeah, I could put in 3, 4, 5, up to 1 billion.